So the vertical line test is really just drawing vertical lines across a relation or a graph. And if the vertical line intersects the graph in more than one point, it is not a function. Okay. So here I'm going to draw vertical lines. And notice each one of these touches the graph at a single point. That means this is a function. However, over here, if I draw a vertical line, notice I touch at 2 points for each one of these vertical lines. And I just need one of these to happen. It doesn't have to be every single one, but in this case, every single vertical line touches the graph in 2 places. This is not a function. Okay. This guy here, although strange looking, is in fact a function. This guy would most likely be a piecewise function, but no line there is going to touch the graph more than once. This guy over here, right, you could draw a vertical line here and say, oh, I'm okay. But if I draw one over here, right, I do touch in 2 places. This is not a function. Okay, so vertical line test isn't too bad. You just draw vertical lines. If you touch more than twice, or sorry, touch more than once, then it is not a function. Next, we're going to be asked to look at a graph and give back the value of the function at a particular value of x. So when they say f of x, they really just want to know what's the y value. And so when I say f of -2, well, I look for where is x equal -2? That's here. But then I have to find out where does it touch my graph? Well, that's right there. That value looks to me to be -3. So f of -2 equals -3. And then f of 2, well, again, here's x equal 2. Go up to my graph. Looks like it's touching maybe up here, which is 5. Okay, so this exercise is nothing more than look at the value of x that's given, trace it to your graph, where what's the ordered pair that's actually on the graph for that value. Okay, here's another example, f of 3. So here's x equal 3, and right here's where it's on my graph. Notice that the y value there is 1. So f of 3 is 1. Now let's take this just a little bit further for a second. Let's say the problem said f of 5. You might notice that for x equal 5, there's an open circle. And that means that the function's either undefined there or we don't know, right? There could be more of the function if we go further out. For instance, the function could be up here somewhere and continue on, and we don't see it. But because we don't know, right, that's an open, we would say undefined for that, just in case you guys run into that situation. Okay. All right, let's continue. Here I have a function. By the way, if you were to do the vertical line test on each of these, right, you would only touch once. Same thing for this guy, so it is indeed a function. And so what is f of -1? Okay, so I go to x equal -1. It looks like I'm approximately at y equals 2. And f of 3. So I go to x equal 3, and my value of y there looks to be 4. All right, so not a whole lot to that. We're going to take it a little bit further here in this next section. So for each of these graphs, they're going to ask us to find the domain, the range, any x-intercepts, y-intercepts, and the indicated values that are asked for it underneath of the graphs. Okay. So let's take a look at this first one here. So the function's domain. Let's actually change up the color here. Okay, so the function's domain. So domain, remember, means x values, right? What values of x am I allowed to have? Well, this thing, it continues on forever on both ends. So eventually, right, it might take a while, but it's going to pick up all values of x, which means that I can get from infinity in the negative direction to infinity in the positive direction. Now, for domain and range, we use either brackets or parentheses. The brackets are if we are equal to or include. The parentheses is if it's not included. Now, you can't be equal to infinity, so therefore we have to use parentheses for those, okay? And this is called set notation. All right. What about the range? Well, range is all of the y values. So what values of y are we allowed to have? Well, again, this thing continues on in the negative direction forever, but it gets no higher than, it looks like, y equals 4. So we would say negative infinity, right? It can go on forever in the negative direction, but the highest it can get is 4, and that's equal to 4. So we use the bracket. All right. Any intercepts? Well, the x-intercepts, where does it cross the x-axis? Well, if we look here, it looks like it's at -3 and 1. So remember, we report those as ordered pairs. So that would be -3, 0 and 1, 0. Or if you wanted to do it as a set, I'm going to use curly brackets for those, it would be -3, 1. Okay. What about the y-intercept? Well, the y-intercepts, looks like it touches right here at 3. So the ordered pair would be 0, 3. Or if we wanted to do it as a set, it would just be the set containing 3. And then finally, the indicated function value. So what is the function at -1? And what is the function at 1? Well, when x is -1, looks like I'm right here. So that point is -1, 4. So my y value is 4. And when x is 1, it looks like my y value is 0. All right. So those are all of the things that they asked us for. Let's see if we can continue and do a few more examples. Here's another relation. We're gonna, if we do a vertical line test, right? Looks like we only touch in one place, so it appears that this guy is a function. So that's good. Okay. Now they asked us for what is the domain or the values of x. Again, this thing continues on forever in both directions. So the values of x, right, are all real numbers, or we would say -infinity to infinity, again, using the parentheses. The range, however, right, this thing doesn't go below the x-axis, right? This is as low as it gets. So if that's the case, then we can equal 0 which means we use a bracket, and we continue on forever above that to infinity. Okay. Then x-intercepts, well, it only touches the axis at one point. It is at -1, 0. It touches the y-axis at one point. That is 0, 1. And the indicated values, they ask us for f of -4 and f of 3. So f of -4. Okay, so I just look and say, where does this function, where's a point on the function when x is -4? It looks like that is y equal 3. And what about when x is 3? That looks like that's at y equal 4. All right, so not too much to that. Maybe the parentheses and brackets you might need to do a little bit of reviewing on, or what infinity is, right? It just means that we continue on forever. Let's see, I think we have maybe one more example here, or maybe two. Let's see. Okay, so vertical line test, this passes, right? This would be a piecewise function because you notice it's not nice and smooth. It has a real abrupt change there. Then what values are we allowed to have in x? Well, it looks like it's going on forever this way. Looks like it's going on forever that way. So eventually it looks like we're going to pick up all values of x again. Okay. What's the range? What are the values of y that we are allowed to have? Well, it looks like it's going to continue on forever this way. So it's going to go to -infinity in the y direction. But the highest it goes is up to y equal -2, right? It doesn't go above this. So -2 is as far as we go. And we can again equal that. All right, x-intercepts. Well, it doesn't appear that it touches the x-axis anywhere, so no x-intercepts. What about y-intercepts? Well, it touches right here, and that is the point x equals 0, y equals -2. And then finally, what are the indicated, the functional values at the indicated values given? So f of -4, x is -4, looks like we're right here. And that looks like that's -5. And when f of 4, or when x equals 4, we're right here. And so that's when y equals -2. Okay. Let's see, I think we have one more example. So let's do this one. We're looking for first, what is the domain? What are the values of x we are allowed to have? Okay, now this one is restricted. Notice it doesn't go on forever on either end. It stops right here and it stops right here. This is not equal, right? Because there's an open circle. This is equal because it's a closed circle. So it looks like x runs from -6 to 0. It is not equal to -6, and it is equal to 0. So not equal, parenthesis, equal, bracket. That's the only one we've seen thus far that has a real restriction on the domain. Okay. What about the range? Well, it's still restricted, right? So it looks like we can go up to 4 and as low as -3. Again, we are not equal to 4. So low is -3, but equal. So bracket. Up to +4, not equal. Okay, so again, this is domain range. All right, C wants to know, does this thing cross the x-axis where the x-intercepts? Well, it looks like it crosses right there. That's the point -4, 0. What about y-intercepts? It does cross the y-axis. Does that right there. That's at 0, -3. And again, if that was an open circle, we would say there's no y-intercept because we're not equal there. All right, finally, what is the function at -4? Well, when x is -4, all right, we've already said that that's our intercept, that's 0. All right, so that concludes this section. So continue on to the next video.